Well, good evening, everyone, and thank you for joining us tonight. Hopefully a few more folks will join us, but let's get started. I'm Louise Shirley. I'm Curator of Natural History for the High Desert Museum. And in part, what inspired me to invite Dr. Autumn-Lynn Harrison for this evening's programme was our new exhibition, The Image Hunter, on the Trail of John James Audubon by Hittners, who is an Italian artist. Hittners sought to retrace the America that Audubon traversed in the making of his opus, The Birds of America. The exhibition is the culmination of that journey, and I encourage you all to come and experience it for yourselves if you're able to. It's open from now through to January 31st, 2021. Some say that Audubon was one of the very first people to ever track birds scientifically using string around their legs to better understand migration. And that got me thinking about how we track birds today and led me to Dr. Harrison's work. The museum is a Smithsonian affiliate, enabling us to offer this wonderful opportunity to learn more about her research. You are very welcome to ask questions this evening via the chat feature. Feel free to submit those throughout Dr. Harrison's presentation, and then we'll select some at the end for her to respond to. We do also have tech support on hand. Thank you very much, Becca, for being here tonight for that role. If you do have any issues technology-wise, then please do reach out and we can help you. Without further ado, it's my absolute pleasure to introduce Dr. Harrison tonight. She is the Program Manager of the Migratory Connectivity Project and a research scientist at the Smithsonian Migratory Bird Center. Dr. Harrison is an ecologist and conservation biologist whose interests include quantitative and field approaches to the study of animal movement and migration, and the implications of managing for species with wide-ranging life histories and transboundary conservation. Prior to joining the Migratory Bird Center in 2014, Dr. Harrison worked for the Society of Conservation Biology for 11 years as a postdoctoral fellow with the Institute for Parks at Clemson University. She is also a trained park naturalist and a graphic designer. For the past decade, her work has focused on large marine vertebrates. She was a researcher with the Tagging of Pacific Predators project and contributed to UN efforts to identify ecologically significant areas for migratory marine animals. Dr. Harrison earned bachelor's degrees in environmental science and fisheries and wildlife science from Virginia Tech, a graduate diploma of science in tropical marine ecology and fisheries science from James Cook University in Australia, and a PhD in ecology and evolutionary biology from the University of California, Santa Cruz. Welcome, Dr. Harrison. Thank you so much again for joining us tonight.
Thank you so much for having me. I wish I could be with you all in person, but this is the next best thing, and I'm really looking forward to sharing stories with you tonight. So I will share my screen now, and actually I need to be enabled to share the screen. I do have a few videos and animations in my presentation tonight, and we did a few tests. They may come off as jumpy, but we hope they're worth seeing even so. So we'll give it a go. Okay. So as Louise mentioned, this talk is partially inspired by the exhibit that will be at the High Desert Museum. And so in this title slide, I've just juxtaposed John James Audubon's interpretation of the black-bellied plover with a modern day photograph from the Alaskan tundra. And I'm going to start this talk with a story about this shorebird. You might have seen this bird pass by your own coastline. They migrate through Oregon, though likely not in all the full finery that you see here of the bird's breeding plumage. And maybe you've even seen them stop and visit for a while, or you've stumbled across a decoy at an antique store. They were once hunted. This bird, I feel, is as dapper as 007 and is certainly as skilled in the art of evasion. The species is often the first to warn other species of danger. And so I like to think of them as the James Bond of the bird world, the black-bellied plover. And like the world of espionage with all of their gadgets used to track the movements of secret agents, tonight I will share with you the tools that we use today to track the movements and reveal the secrets of migratory birds. John James Audubon, the subject of the new exhibit, was a famous naturalist who first revealed the wonders of North American birds really to the world through his exquisite artwork. And he had this to say about the black-bellied plover in the 1800s. I have traced this species along the whole of our eastern coast and beyond it to the rugged shores of Labrador, where my party procured a few, although we did not then find any nest. And so the primary technique that Audubon used in the 1800s to follow shorebird migration was to go to the places that they go. And for this species, he covered their eastern range, but they also migrate along the Pacific coast and in the interior of North America. And he was not in the region to find their nest. They nest in the Arctic region of the world. Actually, they are a cosmopolitan species, but they nest in our Arctic. And as Louise mentioned, John James Audubon is credited with being among the first individuals to band or ring a bird as a way of following their movements. He wrote about this in a biography, saying that in 1804, he attached a piece of silver thread, which might have been more like a wire, to the leg of an eastern phoebe, a pair, I believe, loose enough to not hurt the leg, but so fastened that the bird could not remove it. There's some debate about whether he actually resighted the same birds in the subsequent year, but it's no doubt that he did have this ingenious idea to attach a little marker to the leg of a bird. And it took a while for this to become a systematic scientific enterprise, but by 1920, Frederick Lincoln had organized the federal bird banding program in the United States. He was focused on waterfowl movements and hoping to give information to hunters. And you see in the bottom left of this slide what our bird bands look like today. They're still silver as they were in the 1800s. And we attach these to the legs of any bird that we catch as an individual identifier. And then they also may be resighted during subsequent observations by community scientists, by scientists during capture and mist nets, by anyone who might be in the place that birds are. And in these days, when a bird was recaptured, the metal band was sometimes returned to the federal office with a letter that was always addressed to sirs, of course. There weren't very many women around in these days working in this office. And here is a note saying that this individual sent in a bird band, the date and the location of this. And in this case, this was a migratory seabird that was caught during a fishing operation. And I am a marine ecologist by training, so a lot of my work has focused on the movements of seabirds and seals and turtles, but seabirds and shorebirds primarily these days. And here is an example of a color band on the leg of a Laysan albatross, often used to make observations easier in the field with binoculars when you're seeing a bird zoom past you quite quickly, but the metal band would be on the other leg in this case. And again, another example, this one from our very own Natural History Museum at the Smithsonian Museum of Natural History, had a pretty ambitious program in the 1960s working throughout the Pacific Ocean to band seabirds on many of the US territories and islands. And they kept the recovery information for any birds that were resighted again in a file cabinet that now lives in one of our dusty attics of the Natural History Museum. So I've been working through these records to think about historical fisheries and how those fisheries operations actually caught seabirds at sea, and especially banded birds, to know where they came from. So here was a card recording a Laysan albatross like you see pictured above that was, quote, obtained, which means it was caught as bycatch at Pearl Reef, and this was actually caught by a Japanese fishing vessel. And then in this lower right picture are all of the locations where banded Laysan albatrosses were caught by fisheries from the 1960s to today. And I'll show you now these two little hearts that popped up over the Northwest Hawaiian Islands. These are the locations where the albatrosses were born. So this is where they were first banded. All of these dots came from these two albatross colonies. And so banding information really gave us amazing insights into the migration patterns of birds. We would not have known without these recoveries where these birds migrated to. So some really rich insights from banding data. However, some species, even after 100 years of systematic bird banding, still have very little information. Birds that nest in the Arctic region, for example, are rarely banded. It's very expensive for scientists to work there, and they are rarely captured. Birds that overwinter in the Amazon forest are rarely seen again. So even if they are banded during migration in Texas, for example, it's very rare that a banded bird will be resighted in the Amazon. And so there are some limitations to this simple but amazing technique for some species and not for others. And so we return to 007, the black-bellied plover, and this map on the left shows the black-bellied plover's distribution in the Americas, their breeding distribution in orange, their migration and non-breeding habitats shown here. Overlaid on this map now are the only two recoveries of bands from black-bellied plovers that have ever connected the breeding location to the overwintering location. So in the 100-year history of the bird banding database, these are the only two bands that have shown where a black-bellied plover was born and then where it spends its non-breeding time. So even when we see these data, we think there's so much information available to show us the migration routes, but even today, 100 years after the bird banding program began, for many species, we still know very little about individual connections of their movements. And why is this important in the first place? Why do we want to know this beyond our curiosity and love for birds? Many of you may have seen news reports and been aware of an important paper that came out last year to suggest that almost 3 billion birds have been lost in North America since 1970. And this was co-authored by the former head of the Migratory Bird Center, Pete Mara. So this came from some of the Migratory Bird Center's work, and it was a really sobering call to action for many Americans. And for shorebirds specifically, we have seen really drastic declines, about 50% loss of most long distance migrating shorebirds, but some populations we have lost up to 95% of our numbers. And one of the things I really love about studying studying migration is just the sheer abundance. It's not just a scientific pattern, it's this phenomenon that's like poetry on the wind, and you just see these numbers. And to think about what we've lost when you see these declines is really sobering. And so we are losing shorebirds, but at the same time, there are some species that we don't even have basic scientific information to help us understand where these declines are happening. So the take home for this is that for many species, even with systematic bird banding efforts, we don't know where they spend the year. So we may not always know the reasons for their declines. And most importantly, that means we also don't know how and where to implement conservation solutions to benefit specific declining populations or species. How should we be investing our conservation dollars? Where should we be investing it to have the biggest impact to reduce the impacts of us humans on birds? And so, like James Bond, I'm sorry to the audience if any of you disagree, but this is my favorite James Bond of them all. And so, like James Bond, we turn back to the gadgets and technology that we have available to us to answer these questions. Here, our James Bond is wearing an ingenious backpack designed to propel him likely out of a very tough spot. And scientists at the Smithsonian Migratory Bird Center also use technology to help propel migratory birds out of some very tough spots that we have caused as humans. We use tracking technology to discover information that can be valuable to help bring back our disappearing migratory birds. In the 1980s, we really got into this golden age of technology for the studies of animal movement. And this is when small tags that we could attach to a free-ranging animal could actually communicate with satellites orbiting the Earth. The very first satellite tags that we know of that were deployed on birds were on the biggest birds, of course, because these original tags had very large batteries, even with a solar panel. And so these tags were tested on eagles and swans and southern giant petrels in the 1980s. And they were originally developed through a partnership between the Smithsonian and Johns Hopkins University, an engineer there. And from that initial scientific investment, a new company was born that's based in Maryland, right outside DC. And they started manufacturing and developing these tags. And as the tags were developed through time, they became smaller and smaller. And by the time the mid-90s rolled around, about 10 years worth of development, there was an article in New York Times describing the journey of a bird of prey that had been declining quite rapidly. And these tags were able to discover where that bird overwintered in South America and identify that the birds were actually foraging in areas that had heavy pesticide applications. And so those tags led directly to the discovery of why the birds were declining. And from US Fish and Wildlife Service, Skip Ambrose says, in just a few years, we already know more about these birds and their migration than in the previous 20 years of work. Really amazing. And so the tags are getting smaller and smaller. This is an example of a satellite tag that has a solar panel on top. This weighs about 9.5 grams, and we have used them to track long-billed curlews and broad-winged hawks. And now the tags are getting even tinier. This tag is now only 2.5 grams and smaller than the tip of your thumb. So really tiny, amazing technology. And so now I'll return to the story of the black-bellied plover once more to see if using this technology we could actually discover more than we have been able to with tiny bands. And this effort was done. I have Jenny Rausch from Canada shown smiling here in the Arctic. She was the first person to tag a black-bellied plover with one of these satellite tags. I was probably the second or third maybe. And we all started working together across the Americas, from Argentina all the way to Canada. A number of biologists that study shorebirds came together to track black-bellied plovers throughout their range in the Americas. And so these are just some of the places that we went. And on the right in Argentina, they're all asking, where is the Pluvialis squatarola? Because we got totally skunked on that expedition and we're not able to catch any plovers, but everywhere else we did pretty well. I'll show this video now of what happens when we catch a bird. So we capture this shorebird on the nest. This is a bow net trap that is spring loaded and flips open over the nest. It has a manual release, so we just pull a string and then the trap flips open. It's shaped like a bubble, so it just kind of gives the bird a lot of room over the nest and doesn't prevent the bird from moving once it's in the trap. So I've already pulled the trap. I've raced up to get to the trap after we caught the bird, and I'll show what it looks like when we take the bird out of the trap. This was at the very northern tip of Alaska, in Arctic Alaska. I'm saying it's beautiful. There were a lot of mosquitoes out that day, and yeah, there we go, James Bond in the hand. And so to track the migration of this magnificent shorebird species, we used the tiniest satellite tag available at the time. This was in 2015, I think. A 5-gram satellite tag. And I'll show this again during the question answer, but I have one here with me. The tag is attached with a harness that goes over the legs made of ribbon and worn kind of like a climbing harness. It just goes over their legs so it doesn't conflict with their flight at all. And my colleague Lee Tibbetts and I, she's in Alaska, she and I are working together to attach the tag very carefully and make sure it fits the bird properly. And so once we have the tag on the bird, we do lots of measurements, of course, and then it's the moment of freedom and the bird is released. All of those things flitting around in the front, those are mosquitoes. But we watch the bird until it goes out of sight and it flies away happy. Well, it's got some new bling anyway. And so for the next series of slides, I'll show you just some of the things that we have learned about this species, contrasted again to those two banding locations. So this example here of a male black-bellied plover, 4 years of migration pathways from Alaska to Mexico. This bird visited the same sites to breed every single year. So it would return to within meters of its nest location every year. And that's what you see on the lower right there. Those rings represent the breeding home ranges of this bird and some chicks that were born in subsequent years. So we were able to observe the bird in place and make sure the tag was fitting okay. But they use very different stopover sites each year. So although they were going to within meters of the same breeding site or non-breeding site, the migration sites varied a lot in the Canadian prairies. And that's really because water sources and food sources are ephemeral and sporadic in the prairies. So they change from year to year, and the birds are able to track that. And we have now worked with this species throughout North America and Canada, a couple locations in Alaska. And each color here on this map represents a different breeding location. The triangles are breeding and wintering locations, and the dots represent migratory stopovers. So we now know, sorry about that. We now know how these populations are connected in time and space. And that means if we see one population start to decline, say Northern Alaska, And another population in Canada seems to be doing really well. We can use this information to help identify the causes of those declines or the causes of really successful conservation actions. So this type of information will directly feed into on-the-ground conservation management plans. And so now I hope this isn't too jumpy for you, but you will see an animation of almost all of our tracking data for the black-bellied plover across the Americas. We have some new tracks to add now, but this shows the migratory pathways of, I think this shows 36 individuals, and now we have over 50 that have been tracked. And I didn't give her much attention, but that's a female black-bellied plover on the left there carrying one of the tags. All of the work that I've talked to you so far about with the black-bellied plover was just one species that we are studying through a project called the Migratory Connectivity Project. And we are really trying to help people appreciate and understand migration by studying migratory connectivity, which is the geographic connections of animals in space and time, and then sharing knowledge about what we discover. Our current priorities are to discover unknown migrations like that of the black-bellied plover. And we also work quite heavily on research for species of conservation concern. We test new tracking technologies. So we work with companies to develop new tags and improve their tracking devices. And then we are able to test them in the field, which is an amazing service as well for being able to have the ability to take upon that risk when the technology doesn't work. And that risk is not assumed by a graduate student who has depended upon this. So it works out quite nicely. And then we also share compelling migration stories. And one way we are doing that is by creating an atlas of migratory connectivity for the birds of North America. So this won't be as large as Audubon's elephant-sized book, but we imagine this will be a 2-volume coffee table style of book that will present everything that we know about migration for the birds of North America. For the first time, it will synthesize all of the band recoveries that are in the database. And that amounts to banding information for about 600 migratory species. We have connectivity information, really good connections for about 400 species, and all of the tracking data that have been contributed to the atlas from scientists all over the Americas will be in this book as well. So we hope that that will be a really inspiring way of learning about bird migration. And then, of course, a main focus of our project is to discover unknown migrations. Another species that had 0 band returns, no tracking data before our project, was the Pacific loon that visits the Oregon coast and spends quite a bit of time here during their migrations. This is a species that I have worked with, and I'll show you some results. And over the past 6 years, we have worked with over 50 collaborators from nonprofits, tribal groups, federal agencies, universities to get this work done. So I'm the program manager of this project, and we have 2 other staff members, but that's all at the Smithsonian. So we identify projects and people that are working on species that are priorities. And then sometimes they take the lead on the fieldwork, and sometimes we do. It just depends on the expertise. So through the effort of all of our partners, this work has been accomplished. And the big punchline here, these are all of the bird locations that we have collected through this work over the past 6 years. So not just the black-bellied plover, but actually 23 different species, over 700 individual migration paths on land and in the sea. I've led the shorebird and seabird work, but we have also collected data on raptors, tiny little flammulated owls, common nighthawks, rusty blackbirds, and Connecticut warblers. So these are all of the locations that we have collected with technology over the past 6 years. We use a lot of different capture techniques to catch the birds. This is a mist net in Nome, Alaska, used to catch blue throats. This is the bow net that I showed you in the video. It's closed now and around a shorebird nest. Here's a cannon net that we use to catch flocks of shorebirds on the beaches during either migration or during the non-breeding period. And the net just zooms out over the birds on the beach and falls on top of them. And then we pull the birds out of the net. And then this little contraption, handmade, very elegant, is a leg loop trap that has just a series of monofilament loops that when the bird walks through it, they will tighten on the leg. And so then you go up and just close the wings of the bird and pull that off their leg. And this I use to catch Arctic gulls. In addition to the satellite tags that I introduced to you that have the solar panel on top, we use other types of tracking tags as well. This is called a light level geolocator. It records light, and using standard nautical equations, we convert that to position on the Earth. This is attached to the leg of a small seabird, and you have to catch that bird again to get the tag back. They archive the data on the tag, and instead of transmitting it to a satellite, it's the only way we can get the tag this tiny. You have to catch the bird again and then take the tag off the bird and upload the data. That's on the right. So I'll show you a picture of an Arctic tern, which is the world's longest migrating animal. It has the longest migration of any animal in the world, not just bird, but any animal from the Arctic region to the Antarctic. And the little yellow color band on the leg is where the tag is attached. And this is me recovering the bird 1 year later after it has flown to Antarctica and back. And I obviously could not be happier, even working in very ice-covered lakes in Arctic Alaska. And just because I think it's one of James Audubon's most beautiful prints, here is his Arctic tern. I just can't get enough of this painting. We, as I mentioned, we also test new technology and we improve the attachments. We work to improve the attachments of the tags on the bird. So we want these tags to have minimal impact to the bird. We try to keep the tags to a very small percentage of their body weight. This was the very first really tiny GPS transmitting tag available for birds. So this is sub 5 grams, only a 3 gram tag. We tested this tag on shorebirds in Texas, and the lower right panel there shows the antennas had been pulled out. So that first test was not successful, and the manufacturers went back, improved the tag, and then we redeployed and tried again. We have also worked on testing attachments that are very lightweight and that can expand and contract with the birds. As you can imagine, these birds are making long migrations. They lose a lot of body fat during their migration, so they become very skinny. And then when they stop to refuel, they plump right up again. So we were testing an attachment that could expand and contract with the bird's body weight, which is a pretty amazing advance. And so that's pictured on the top right. And now for this last series of slides, I'll give you some examples of how we are using these data to help birds. And this will have a few more technical examples about some of the science that we're doing and have some scientific terms, but that's what the question and answer period is for. So I'll zoom through these to give an overview of how we're using these data, but please feel free to ask questions. And to just show you the Audubon prints of some of the species I'll be talking about, the Connecticut warbler, long-tailed Jaeger. It's called an Arctic Jaeger here, but this is the long-tailed Jaeger, and common nighthawk. And I'll throw in another species or two. So first, the Connecticut warbler. The paper I mentioned that was published last year estimated that 2.2 million have been lost since 1970. A postdoctoral associate working with the Smithsonian, Mike Hallworth, deployed those tiny little geolocators, the light level ones that you have to recover, on Connecticut warblers. And he wanted to really understand what was driving this big loss of Connecticut warblers. So he used tracking data shown on the left, combined it with breeding bird surveys. So these are counts of birds every year. And then also combined that with a picture of forest loss throughout the hemisphere. And so he wanted to see if forest loss could predict those population trends across the Americas. And he found that forest loss on the breeding ground seems to contribute more to declines than forest loss during migration or during the overwintering period. So this is an example where his work and our tracking work has helped identify that conservation actions to reverse these declines may need to be prioritized on the breeding grounds first, and that's a good place to invest money. Common nighthawk, the fabulous Ellie Knight, as a graduate student at the University of Alberta. She started a really ambitious project to track common nighthawks throughout the Americas, an estimated 26 million lost. And she was really interested in why some populations seem stable and some are drastically declining. But to answer that, the first thing we need to know is where these birds are migrating. So she worked with partners all over the Americas to track common nighthawks representing 12 different populations. That's what the map shows on the left. Some of the example pathways on the right. This was a really ambitious PhD project. And what she has found is that common nighthawks from all of these different populations actually take a common migration route. And they also share a lot of the same overwintering areas. So they mix up. So that means that it's a little harder to determine why each population may be declining or stable. But she did notice that some arrive at their crossing of the Gulf of Mexico, which is physically demanding to cross a big body of water. They arrive there at different times. So her next step is to look at what environmental factors might be happening at those times that could affect some populations over others. For example, a population may arrive during hurricane season while another is just after. So she'll be looking at that next. And then a couple of quick examples, and we'll be wrapping up soon. This is a species that I've studied in partnership with scientists at USGS. Pacific loons did not even have enough data to have population trends estimated for the science paper. So it's one of those species that's really difficult to monitor, and that before our work had no migration data. But there are conservation buffer zones in place around the nesting habitats of loons in the National Petroleum Reserve of Alaska. So this is a place where oil development is active, but there are management interventions in place to help limit activity around nest. So we used our tracking data to see if these buffer zones were an appropriate size based on the actual breeding movements of the birds. Now that we have data, before they were just hypotheses really. And the figure on the left just shows an example of a nest home range for one of these species. We did this work actually for 3 different species, yellow-billed loons and red-throated loons and Pacific loons. And what we found is that the nest site, the nest movements were very small. Birds hunker down on the nest and they pretty much stay there. But once they start feeding their chicks, they start moving out into the sea, where at-sea oil development might overlap with their movements. So we found that on the nest, the buffer zones are appropriate habitat interventions, but once they are at sea, there's no protections for them. The next step for this species is to look at different habitats and threats in their overwintering areas. These movements are from the same species, but two different populations. So tags deployed on the north slope of Alaska for Pacific loons. These birds travel to Russia and Japan. And birds nesting in the Yukon-Kuskokwim Delta go your way toward Oregon and California and Tijuana. Same species, this amazing migratory divide. And then finally, I have been studying our 3 species of North American Jaegers, Pomeran, parasitic, and long-tailed, and another group of species that were not estimated in the Rosenberg paper. The only information on their migrations comes from a few specimens that were collected in the 1960s. So that's incredible that we still know so little about this species. And our goal was to use our tracking technology to discover their unknown migrations and to look at whether they are primarily spending time on the coast or whether they are out in the open oceans where there are still very little protections. So just a quick peek at some of the newest migration data that we have for our project. This is a long-tailed Jaeger, and you can see the satellite antenna coming up from the back. And these are movements of this species from Denali National Park in the North Slope of Alaska, again, spending time in the California Current on the Pacific coast and ranging all the way to South America. And then the parasitic Jaeger taking very different routes across the ocean, using the open ocean, going to New Zealand and Papua New Guinea and the islands of the Southwest Pacific. So these are sister species, very closely related species. They nest in the same tundra habitat right next to each other in some cases, but they take very different migration patterns. So this also makes us think how these two species arose and their evolutionary history. And when you see tracking data like this, it really drives home to you how for these birds, there are very few international borders. They cross countries, boundaries in minutes, really. And so these data in the ocean for seabirds have been used to inform a new ocean treaty. And I have been involved in some of these efforts and discussions with the Convention on Biological Diversity and the United Nations. And in one of the very first negotiating sessions for a new ocean treaty in 2018, I was asked to present some of the tracking work that we have collected for seabirds. So that was in this full General Assembly room where you see all the people with their translators on their ears and the country's names in front of the placards. And I had 8 minutes and 8 minutes only to tell this story. And the stories of migrating animals has really helped people realize why a treaty for the oceans, a new treaty, is necessary. When you see in this map on the top left, all of the places outside of those white boundaries, those currently don't fall under any type of official governance restrictions. They are a global commons. And many of the species that we study spend a lot of time there. So this new treaty will be addressing how to best manage those parts of the ocean that still are a global commons. And that should be wrapping up in 2021 with a new treaty. And so the work that I have presented act of Congress in the 80s to address this worry that we were losing North America's birds. We are dedicated to fostering a greater understanding, appreciation, and protection of birds. And so I'll close tonight with the message that although I've presented to you this really high-level kind of scientific view of the research that we are doing to help reverse the declines of migratory birds and inform management actions, there are so many things that all of us can do to help protect birds and to make the world bird friendly. So these are just 7 simple actions that we can do to help birds. make windows safer by using window clings, report when you see birds through apps like eBird, use less plastic, think before you buy fish to make sure that those are bird safe practices. And definitely native plants in yards have a huge impact on birds. I think while many of us have been staying at home more often during the pandemic, those little bits of joy that flip by our windows, you know, they're everything to us right now. And so anything that you can do with these simple actions, even, you know, drinking your coffee, bird-friendly coffee, which helps to create a biodiverse forest for birds. You can drink your coffee and feel happy about that, but at the same time, think about all it's doing to save birds. And with that message, I'll just close out tonight with some links to some of our social media feeds. We have a website and a feed on Twitter and Facebook where we share migration stories every week on Tracking Tuesday.
Do you mind if we finish up by me asking you a question?
No, not at all.
You're obviously very passionate about migratory species and have dedicated your career to studying them. But at the beginning, you were showing those devastating losses that we've seen over the years, largely due to human impacts. Do you feel optimistic about the future and the survival of some of those species?
I do, and I have seen. I mean, I'm a realist, but I have seen conservation work, and you know, one species that I work with is the brown pelican. Mm-hmm. It's quite an amazing success story, and it's an easy one to point to. There was a clear driver of their declines, and that was DDT. So there was a clear cause and effect that was easy to identify. That's not the case for a lot of shorebird species. There are multiple competing effects. But I'm now studying a population of brown pelicans in Maryland, and pelicans never nested in Maryland before the 1980s. John Smith never recorded them in his Chesapeake logs. They had never been seen. And what we think has happened is that after DDT was banned, there had been some beach development. This is all conjecture, but essentially the brown pelicans from the Carolinas, from Florida, got this release from DDT being banned, started reproducing at really high rates. And we think that those birds from the Carolinas started moving up the coast and finding new places to start their nesting colonies. So now we have huge thousands of brown pelicans in the Chesapeake Bay, a marine predator we never had before. So that gives me optimism both about the health of the Chesapeake Bay, but also that recoveries are possible. Seeing that a recovery is possible makes me just more optimistic. And you know, seeing that a new ocean treaty, it might have taken 20 or 40 years to get there, but it's happening, and they're listening, at least at some level, to science and integrating these stories into their thoughts. That's quite amazing, I think. And so those experiences have made me optimistic, even in the face of some real bummers too. Yeah.
That's wonderful, thank you. And that seems like a really nice note to end this evening's programme. Thank you so much again for joining us, sharing your work, and for the fantastic research that you're doing. Thank you everyone who joined us, and we'll be sharing the YouTube link to this video, so we encourage you to share it with friends and family who also might be interested in hearing about this work. Thank you everyone, and have a good evening.